Hello guys, good morning once again. So in this class, we'll be continuing where we stopped at on object-oriented programming, which we'll be diving in on the concepts of object-oriented programming. So, like I mentioned, object-oriented programming have four major concepts. So each of them helps us to create modular application. So the concepts include uh, inheritance. Let me, so the concept include inheritance. It include um, encapsulation. It include polymorphism. And the last one is abstraction. All right. So these four are the concepts of object-oriented programming. So inheritance is like a parent that it's like when a child gets some kind of features of the parents, it is the name implies. So inheritance is like the child class is getting some properties, is able to access the properties of the parent and for itself. For instance, let's look at the objects we created in the last class. We created an object of smartphone. Now, we know smartphone is an object that has different features. And a smartphone is one type of phone. We have land phone, we have other phones that we know. But smartphone is one of the phone that we know and is one of the most common phone that was used today. So we all know, even though smartphone is kind of different, the major features of all phone is they can you can be able to call, you can be able to do their properties include the battery capacity, SIM slots, ringing tone. Basically, all phone have those ones, either smartphone or not. They have those. Also, all phones should be able to call because the major use case of phone is to be able to make phone call. So we created this class, this object of phone. Now we can also add a function to be able to call. In fact, we can also, don't let us do that yet. We can also pass the name of the person we wanted to call, but don't worry about this yet. Now let's just print calling. All right. So this is the properties of a phone. Now, from this phone, we can create a smartphone. When creating a smartphone, all this property smartphone, I mean, we know phone already have them. So when creating smartphone, we do not need to create all these properties again. Instead, we can extend from the parent child, which is phone. We can extend phone as the parent child. And when we extend phone as the parents sorry, we can extend phone as the parent class. And when we extend phone, we'll be able to access all the properties of phone in smartphone. Now let's see. Now this smartphone, we can extend, let's say extend phone. Now let me remove all this. Now I want to do something here. So I want to first remove this. So I can't do that. Let me go back here. So now we extend this phone class. Now all the properties of phone is now given to smartphone. For instance, we can come here, let's say ringing. So inside the ringing, let me just put the function here. Inside the ringing, we can have access to call. You can call this function. You see, we are able to call this function. Now, before I go on to this is, if you notice, this is throwing error. And that is because the parent class, which is phone in this case, have some properties that need to be initiated. Do you get this phone? Hello,
I
please, if there's no noise in your place, please unmute your mic so that we can keep the class uh interactive. All right. Good. Now, so from here, we can also instantiate the parents, I mean the properties of the parent. For instance, now we know that phone has the properties of battery capacity. Here we can also initiate battery capacity. Uh, is that sorry, I don't think we can access it directly like this. Oh, okay. Now look at this. Now this, if you look at this, you can see super dots, ringing tone, and super dots. Now, this super keyword is letting our programs know that this properties is from the super class. You know, this is this class, this keyword is letting us know that these properties is the properties of this class, is the properties of this class. Now, for super class, is letting our compiler know that this property is the properties of our parent class. And what is the parent class in this case?
phone.
Phone. Exactly. So phone is our parent class, while smartphone is the child class. Now, This thing. Hello, I hope you guys are following. Favor on the board. Okay. So now let's move on. Let me remove all this one. Okay. Should we just still use it? Now, sorry. From this constructor, we can pass the value. Let me comment this one out. Let me comment this one out. Do not need them for now. Then we can pass the properties, I mean the values of the property we commented out. So let's say OS, then this OS is iOS, right? Then the battery capacity. So let's say 2600 milliampere. Let's say what is it again? SIM slots. Let's say it's a two SIM phone. And also, we do have, what's the last one? SIM slots. Capacity in ringtone. I thought we have ringtone in the child class as well.
Yes, sir.
So this would be an issue. No, okay. No, we do not have it in the child class. We only have it in the parent class. So now let's call it iPhone ringtone. So in essence, inheritance allows us to be able to extend a parent class and be able to use the properties of the parent class. Let's look at this document. So this one, okay, this starts from encapsulation. So, okay, look at this. So inheritance is a mechanism that allows a class, that is a class, to inherit the properties and method from another class, superclass. So in this case, our smartphone class is the subclass, while phone is the superclass. All right. This promotes code reuse and establish a hierarchy relationship between class. Now, if you look at it on a higher ground, I mean on a lower ground, phone is the basic uh blueprint, while the smartphone is can be created from phone, which is on the higher side of the hierarchy. Now, look at something. Let's say this call, want to have another. we want to have different ways of calling in for each object we created from a superclass. Now, this superclass can also be, I mean, the superclass can be extended by many subclass. In this case, the phone class can be extended by many other phone variety we created. So let's say instead of smartphone, we also have another kind of phone. Let's say we have land phone. In fact, let's create an object of land phone. Land phone. Now, hello, please help me create this class. Hello,
Sir.
I want you guys to help me create this class. So, D-boy, please unmute your mic. Favor, please unmute your mic. So I want it to be interactive. So how do we create a class here? Hello, D-boy and Favor.
Sir.
Please help me create a class here.
Create a class for learn from.
I can hear you. Please be audible.
Yeah, class.
Okay, let's write class, right?
Yes. Um,
Then,
learn from.
so I should use, in which case, so land phone. So this is our land phone. Now, let's say we created this class. We do not have any properties inside it yet. So, and
Yes.
extend, we can extend phone. Mere creating this class, we have access to everything in the phone class. Now, let's see. You know, the land phone we created, we do not have any properties inside it. Now, look at this.
Yes.
Let's go back to our main file and create a land phone. Create object of land phone by doing what? D-boy, I'm not hearing your voice. Oh, what's going on?
Yeah, I mean,
Help me
yeah,
create
I
the
mean,
object of land phone. We've created the um, blueprints. Help me instantiate the object of land phone, please. D-boy, what's going on, please?
yes, yes,
I can hear you. I
I'm
asked,
here.
okay, I'm asking you a question. Please answer.
Yes. What do you ask?
I want you to help me to create the instance of land phone, the blueprint we just created just now.
Yeah, it's going to be it. Maybe buttons.
No, no, we are not creating properties.
Okay.
We just want to instantiate the object. We've created the blueprint, and it doesn't have any properties for now, except that it extends the parents class, which is phone. So we want to instantiate the objects of the land phone. What is it?
I don't know.
You don't know, okay? What are you saying? You guys are you are not paying attention in this class at all.
Instantiate it.
It is obvious. You are not in this class at all. See, I'm telling you, this is the basic. You are missing it already. So by well, I can't say more than what I'm saying, honestly, because it's obvious you guys don't want to you don't want to pay attention. We are in the class, you are doing another thing. This is basically what you are seeing on your screen, and you said you don't know. This is it's because of you. We should have done what we are just doing today in the last class. It's because of you and Fifo did not join the class. That was why we suspended it to today. And today here again, you are telling me you did not. I reviewed the class for you last class. Did I not? I reviewed everything, something we've done. I had to go back to explain it right from the beginning. And still here today, you are telling me you don't know. Is that supposed to happen? This is not going well, honestly. This is not Why would you be telling me that you can't instantiate an object now? People, please, how do you instantiate this land phone? Are you there, people?
Yes,
Hello,
yeah.
people. So I'm asking you a question. How do we instantiate this object?
And um,
Land phone.
Land phone, yes.
Home.
Phone, let's just call it land phone instead of calling it phone. Let's call it land phone. Then what? I can't hear you.
Home.
Home. Home, what did you call it?
Land phone.
Well, I can't wait for you guys anymore because you guys are my witness that I wait enough for you guys. So, to create an instance of an object, you simply create the data type, I mean the class as the data type, the variable name, then is equal to which you use to assign, then you call the constructor that we created. Inside this land phone, we have this constructor. We have this is our constructor. This is our constructor. So we have this constructor and we just need to call it A. So then we pass the value that are coming from our superclass, which is battery capacity. Let's call it 1000 mAh. SIM slot. Let's say it has one SIM slot. Then ringing tone. Let's call it land. Under close. Okay. All right. So this is the instance of our object. Now look at this. Remember, we do not have anything inside land phone. We do not have any properties and no function. So from here, we can print, or oh, let's call the functions to call. You can say land phone dot call. As you can see, we are able to access this function call. And this function is from here. Hello. This call function is from here. Hello.
Alright.
I mean, this
So the
function
function
is
is from
from phone, which is the super class. Now let's pass the parameter of. No, we don't need to pass parameter. Let's just call ring into. All right. So now we can. Let me clear this. Not find. Okay. Okay. So as you can see, we are able to call a telephone, calling land phone ringtone. So by extending a class, we will be able to access the properties of the super class. Here's my browser. Oh, here's my browser. Now, the next one is encapsulation. Okay, so now encapsulation is the bundling of data and method that operates on the data within a single unit, known as class. It hides the internal state of an object from the outside world, only exposing the necessary functionalities through well-defined interface. I think we discussed this in the last class. That I mentioned, I showed you, I think I showed how to use, I mean, the access modifier in Java, which I showed private, how to declare private variable.
private, public, and protected.
Yeah, so that is basically about encapsulation. So
Sorry, sir. Pardon me, sir. So
encapsulation,
basically, sorry, sir.
okay,
Pardon me. Encapsulation basically is just to control the access to whatever variable or field that
exactly,
is inside. Okay.
exactly. So it basically allows you to hide or to control the access of either functions or variables. I mean properties. So let's say, for instance, this our smartphone. I think I did something like this in last class. I- I'm just remembering here. I know I did something like this. That we created this IMEI. So this is a private variable because until except we use this function, this getter and setter function, we will not be able to call the to use or instantiate what IMEI is. So basically, uh, encapsulation allows you to define your class. I mean, to define the access of your class. Now, in that, to create a private uh, variable or private class or private uh, function, you simply put underscore. In some other programming language, if you see something like private, then private like this, so it's the same thing as this in that. Some other programming language have different modifiers. So Java it has uh private, it has protected, pro, sorry, oh, what am I doing? So if you see something like this in any programming language, in especially in Java program, because yeah, Java, I keep mentioning Java because that is very close to, I mean, that syntax is almost similar to Java syntax. Do you get? And Java is also an object-oriented programming language. So that is why we keep referencing Java. There are other programming languages that are similar to that as well. So what? Let's keep referencing Java. So in Java, you will see something like protected. You will see something like private and public. So privates are the private variables. You will be able to access them only within a class. Protected variables can only be accessed within a file. For example, if we create this class and we make it a protected class in Java, not in that, right? So if this class is protected, you can only use this class within this file. You won't be able to use it in main.dat or anywhere. So I mean main.java or anywhere. So as you can see, in that, encapsulation is achieved through access modifiers such as public, private, and protected. By default, members are public, but you can also mark them as private using underscore. So to use this example, it creates balance, which is a private variable. Now, deposits, withdraw, and get balance. They have these three functions, right? So whenever they inside the main file, whenever they instantiate this, they will not be able to. Let's just do that and let's do that again. Let's say this is our class. I mean, this is in this our class. IMEI is our private variable. This variable, in fact, this IMEI should be properties of it should be properties of phone. But let's just leave it like this. So the IMEI you can see when we instantiate, when we create this constructor, we do not pass this private variable to it. And that is because private variable would not be assigned. The value of the private variable will not be assigned with the constructor. Are you getting me?
Yes, sir.
So now we have these two functions called getter and setter. To create a setter, you simply put set your function name, then you open your parentheses, you put your input inside your parentheses, then you assign this. What did I call this? Can anyone remind me? Whenever you see these properties of, this keyword, this, what does that mean? In front of any variable, what does it mean?
So that means you're referring to the instance field of that particular object.
Yes, because that it means that that properties you are trying to reference is the properties of that particular class. So meaning that this IMEI, that is this IMEI, the IMEI of this class is equal to the IMEI that is coming from this function. So don't be confused here. This first one is the properties of this class. Why this one is the IMEI that is coming from this function. All right. Then we return, for getter method, since we are not passing any value to getter method, you don't need this parenthesis. You just open this one and return your value. So now how to use it is in our main file, you can say iPhone exam dot set IMEI is equal to, let's use 111. All right. Now you can print it here by saying iPhone XR dot get IMEI. And if we print this, we'll be able to see our IMEI printed to the console. So we'll use setter method here and we'll use getter method here. I expect you guys to ask a question around it. Is there any question? D-boy, please unmute your mic if no noise in where you are. In fact, please
Yes,
unmute your mic.
yes,
Now, did you get this?
yes,
Can I ask you a question? Can I ask you a question?
yes.
Okay. A s- setter function is a setter is a function, right? A getter is a function. Now, and in fact, how do we call a function? That's the first thing I should ask. How do we call a function of a particular class? How do we call a function of a class? Evo.
What to you?
Evo. And D-boy.
Sir?
How do you call a function of a class?
So how you did it here? That's how we are going to call it.
function
I
of
know
this variable.
I know how I did it. I'm just asking you to tell me how we should do
Yes, so we are going to get the main body of the function.
it. The main body of the function. I don't get that.
To begin with,
What do you mean? What do you mean the main body of the function?
yeah, he was talking about device which is an iPhone XR.
Okay, so instead of calling it the main body, this is the variable name of this object. So we are going to use the variable name, then what? Then the function name, right?
Yes,
Now, this line phone dot call, is it a function or a property?
here is a function.
Okay, good. This iPhone dot get IMEI, is it a function or property?
Is a function.
Okay, you said it's a function, right? As
Yes,
well, this iPhone dot set IMEI, is it a property or a function?
is a function.
It's a
It's a
function.
function.
It's a function. Now,
Yes.
why is this function different from this function and different from this if they are function?
This one,
This
this
one
one
is
is
this one is
get
get
setter
get setter
Are you
and
guys in the same place? D-boy and Favor.
Yeah.
you are saying
I can hear you.
we are here, we are
You are
same
both in the
place.
office.
Yes,
Okay.
Everybody,
That's why your voice is echoing through and that's one. I mean, through Vivor's mic. Okay, so I can hear your explanation. Go ahead.
yeah. This one is get setter.
Okay. It's a getter function. It's basically.
Yes,
So one is a getter function, one is setter function, while a normal function will have opening and closing brackets, while uh, a getter function will not have. At, as the same as declaring a getter function and a setter function. A getter function will not have opening brackets and will not take any inputs. While setter function will take inputs of the property you want to set to. I hope you guys get to that point. In fact, I, I'm happy you are able to answer that. All right, so let's move on. Now that is about encapsulation. That is about encapsulation. In fact, this is basically the answer to the assignment I gave you. But if you use this, I will know, right? I will know. So let's move on. You see the example of inheritance. Let's say we want to create animal. Oh, sorry, I was trying to explain something on the inheritance. Sorry, I think I forgot. Now look at this land phone. Let's say, we already have this function of call inside phone. Now let's say inside land phone, we have our own we have different way of calling on the land phone, right? Phone generally to call you just input your number and you input the number and you dial the number, right? But let's say for land phone, in this case, there are different way you want to call a function. I mean, you want to implement a function. Now, we can override a property of a, a super class. Hello, let me do this. Let's say inside the phone, we already have a function of call. Now, inside the land phone, we want to override that function. So we can say call. In fact, don't let me use suggestion. We can use something called annotation. If you see something like this, I don't want to use, oh, okay. Let me just do this. Now, if you see anywhere you see this at Kinikon or in that programming language, this is called annotation. Now, if we override a superclass, we should annotate that function with override. So now, this is an annotation. Then we call void call. So this will understand that whenever we call this, okay, let me just do this. Print calling from override function. Now look at this. Remember the other time that we called, remember the other time that we called this function. The other time we called this call. The other time we called this was printed to the console, calling land phone, right? Now, and that was because this call is directly from phone, and this is the function from the phone, right? Now, since we override it now with our own function, I mean with its specific um method, we can print, you see, it says calling from override function. So instead of calling from the superclass, it's calling from the local class, I mean from the sub class. If we call smartphone, let's print this one as well. iPhone.call. Now, look at this. Calling iPhone ringing tone. This one, this calling iPhone ringing tone is calling from the superclass, and that is because we do not override the call function inside the subclass of smartphone. But since we override it inside the land phone, that is why land phone is calling from the call function in the land phone class, while iPhone XR is calling from the super class. I hope you guys get that. Hello. Hello.
Hi.
Do you guys get what I just explained, or should I come over? I mean, should I
Understand.
explain it again?
Understand, sir.
D-boy Vivo, should I explain it again, or you guys are okay with this?
Yeah, the inheritance.
The inheritance, I should explain it again.
Yes.
Okay. Basically, inheritance um is the ability of a subclass to gets the property to extend a superclass and get all the properties and functions of the superclass. So let's bring it down to the real world. Let's say you want to create a animal. You know, we have different animals. We have dog. Okay, let's say today you want to create a dog. What are the properties of a dog? Dog have four legs, right? Dog have, hello, please be
Yes,
Sir.
right.
responsive. I want you to
Yeah.
now. Dog have four legs. Dogs have they have
Yeah.
heads, they have tail, they have their eyes in front of their heads. Am I correct?
Yes.
Okay. Now,
Yes.
now, so you create a dog today. Another time you want to create another animal. You want to create a goat in this case. Now, remember that dog and goat, they have similar properties. That is, goats also have four legs. It has tails. It has their eyes pointing in front of their head. All right. You created that one again. Another time you want to create a sheep. The same properties. You have to write it again, right? Now, you remember all these animals, they have similar properties. That is, you can create a class and call it animal. Now, this animal class, you put all the properties that all of them have. You put it there. You create that class. Then you can now create your dog, then extend the animal class. When you extend the animal class, instead of you having to write all those function again, all those properties again, you can directly access those class in your dog class. That is, you can access the properties of the leg, you can access the properties of the eyes, you can have the properties of the tail in as much as you extend the animal class. Hello, am I communicating? All right. Now, this is what we did here. We know that phone is the basic what should we call it? It's like the basic GSM phone, right? Phone is the parent class for all any type of phone that we want to create. Then after we create the phone, from phone we can create uh we can create
Yes.
smartphone, we can create land phone, we can create uh touch phone, or what do we call that? Those small phone that we used before before this all this Android phone comes in. So you can from that class, since all of them have some similar property, we can create them and then we will be able to access the properties of the main of the superclass phone in this case, then inside all those subclasses. Hello,
Hi.
D-boy. Did you get it?
Yes.
Now, also we can override a functions of a superclass, and that is what we did inside smartphone. I mean, inside land phone here. We are able to override this function of phone, I mean, this function of call to implement our own local call. I hope you guys get it. Should we move on, or
Sir,
is there any other question?
No, no other, no other
Hugo,
question.
is there any question?
No other question.
I get. Habib, hello. You can as well. Hello, Habib. Is he still in the office?
Yes.
Please ask him to unmute his mic. Hello, Habib.
Yes, I'm muted.
I can hear you.
Hello, sir.
All right. So, are you following us?
Yes, sir.
All right. So basically, what we are doing is we are looking at object-oriented programming language, where everything we create is from the point of view of an object. And what is an object in real world application? What is an object? Your table is an object. You as a person is an object.
Yes, sir.
Your dog is an object. So an object is an object now, and everything real world entities they are objects. Now, to create an object, you have to create a blueprint of what an object is. I mean, to create an object, we have to know what would our object have. So we want to create a table. We'll first draw out the plan of what we want our table to look like. So by drawing that out, we are creating a blueprint. We are creating a structure for our table. So bringing that back to programming language, to that programming language, creating the blueprint is creating the class. So in programming language, class is a blueprint of an object. Are you following, Abib?
Yes, sir.
So class is a blueprint of an object. It is inside the class that we draw out the structure of our object. Now, after we draw out our blueprint, our structure, we have something called constructor. This thing you are seeing here is a constructor. Now, constructor basically is just a function that helps you to instantiate the properties of your objects. So in this case, we have land phone, and we are able to use this land phone constructor instantiate the properties of superclass, which is phone. So, and we talked about we are today we are talking about concept of object-oriented programming, which we include inheritance and uh, encapsulation. So the inheritance is an object when an object extends another object. So in this case, land phone extend phone. So now when an object extends objects, one will be a superclass and one will be a subclass. The superclass will be the one will be on a low level that has most of the properties that another class can inherit from. The subclass is the one that extends a superclass. Are you following?
Yes,
yes,
sir.
sir.
All right. So And in a subclass, you can have access to the properties of the superclass, and as well you can override a properties of a superclass. Do you get it?
Yes, sir.
Now, we have encapsulation. Encapsulation allows you to control the access of your property. Now, let's say you are creating a a bank account. You are creating an object for a bank account. You want users to be able to see the balance, but you don't want them to be able to explicitly have access to that balance, meaning that you don't want them to modify it anyhow. You don't want anybody to just access it anyhow. So you can make it a private variable. So in this case, we are using smartphone as our object, then
Okay.
IMEI as the variable that we want to hide from anybody. So this IMEI, we declare it as a private variable. Then we have two functions. When you watch the lectures, you will see how to create functions. You will learn about those. But we have two unique functions called setter and getter. Now, setter allows you to set the value of a property, and getter allows you to get the value of a property. So to 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 modify a private variable, you would have to use a setter function and a getter function to get the value of a private variable. I hope you understand.
Yes.
All right. Is there any other question from anyone before we move on? I guess that is no question, right? Now let's look at polymorphism. Polymorphism allows objects of different class to be treated as low. All right. Polymorphism allows objects of different classes to be treated as object of a common superclass. This enables flexibility and extensibility in the code. All right. Let's say we have object of animal. We have object of animal. Hello,
Um,
please. That person that's making it should mute his mic. All right. Now let's say we have an object of animal. Now each animal can speak, right?
yes.
Okay. No, don't let us use speak. Let's use movements. Each animal can move, right?
Yes, sir.
Now, if a doggy can move by walking, so if a dog can walk but can move by walking or by running or by juggling, a bird, how does a bird move? They either walk or fly. All right. Now, meaning that if we create an object of animal and we have a super function of movement, movement cannot be the same thing for both dog, horse, or and fly or bird. Sorry. So in this case, we can create an object of movement. We can create an object of movement. And this, sorry, let me recap what I just said. We can create an object of movement, yes. Let me write that in here. So, oh, we don't have animal. Let me bring it back to phone that we are looking at. So, sorry, excuse me. Let me look at this once again. Okay, sorry. Sorry about that. I was explaining something else. Now let me review that. So polymorphism is allows you to treat objects of different class as the same superclass. So in this case, let's say we have a function that uh, let me see how I can structure that class. Let's say we have okay. So polymorphism basically, let's say we have this. We want to take I'm looking for a perfect example to explain this actually. Hmm, Example. Let's say we have another class. Let's call it uh, uh hold on please. Let's say we create an object of a person. A person. Let's say we create an object of a person. And that person have a name. I'll be quick over this. Name was let's call it online. Then the person has a phone. Now, okay, yeah, this is perfect example. Now, the person has a phone, right? Now, we have different objects of phone. We have smartphone, we have land phone in this case, right?
Yes, sir.
Now, we want to accept the phone of this person in this class. Now, we can say smartphone, right? Is equal to Then let's use constructor to accept the phone. Yes. Let's make it required. So we create object of this person. Now this person has a phone. Let's do this. Let me comment this out. Now we create person photo. Let's name it. Let's name it person one. It's photo. Now look at this. We want to send the type of phone the person is using. So since we create the object of phone to be smartphone, that means we have to pass exam, right?
Yes, sir.
Now look at this. What if the person now changed to land phone? You can see there's a problem here. We would have to go inside this person class and go and change to land phone again, right? Hello.
I
Hi.
All right. So the first person, why the person is using uh land phone. Now, anytime the type of object change back to smartphone, we'd have to come here again to change to smartphone. Now, polymorphism gives us the flexibility of using the same treating the same subclass as the child of the same parent class. Now, instead of doing this, we can just say that he used what? He used phone. Oh, sorry. We can just name the properties to be phone. Now, if this is a phone, this will accept any properties, any child, in as much as those child extend the same parent class. So in this case, whether we pass land phone or we pass iPhone XR, it's still going to take both of them because both of them extend the same parent class. Hello.
I
So because both of them extend the same parent class, and that is why we are able to pass phone. We are able to pass smartphone to phone. Is there any question?
no, sir.
All right. Let's look at the last one. So, for example, here, look at this. You are trying to draw a shape. All of them, you create superclass. Now you can extend the you know rectangle is a shape, circle is a shape.
Yes, sir.
So you can when you extend each of them, when each of them extend shape, you can you can pass the data type as the shape and pass the value of different shapes. Just like what they did here. The data type is shape, the variable and the constructor here, the object here. The object is a circle, while the data type is a. All right. Now, last concept is called abstraction. Abstraction is it allows you to hide the complex implementation. Abstraction is the process of hiding complex implementation details and showing only the essential feature of an object. Now, let's look at this. So, now, let's see this phone object. This phone object, we can make it an abstract class. By making it an abstract class, it means that every function that calls it, sorry. Now, when you make an object an abstract class, you are trying to hide the implementation of the functions of that class. So in this case, we can remove this curly bracket and do this. Now, when you do this, you see that we do not implement, we just create the function here. We do not implement it inside the phone class. Are you following?
So,
Now you can come inside this. You see that this start to complain when we have not override the function of call, because when you extend an abstract class, you must override its function. Hello, am I communicating?
yes, sir.
Yes.
So you must override the value, I mean the function of the class. So that is why this one is complaining. Now, like this, we have called the class and we put our implementation in here. You can say print, print. Wait, what? So abstractions allow lets you now look at this. If we come to main and we try to say, let's say we say land phone dot call and hyphen xr dot call. Now look at this. Instead of when you oh, mm, let me use another abstract class. Let's say I declare abstract Now, note that a class, where is that echoing coming from? Note that a class can extend more than one class. Eh, Each each class okay, sorry. Extend can extend at least, I mean, they are at most one class, but I think implementation. So we can implement more than one class, but extend can only is limited to one. So let me remove this for now. I wanted to now let's use this. I'll comment this for now. I want to show you when you let's say call. Let's say we have call in here. We have the function void call and like this. In here, when we now inside this smartphone, if we try to call it like this, it would navigate us to this function instead of showing us the implementation directly. Instead of showing us this implementation directly. So it's basically hiding this function. Where is it? So it's basically it will hide this function, this implementation. It will hide this implementation and would it will show this instead as a feature. So abstraction is the process of hiding complex implementation details and showing only essential feature of an object. It helps reducing programming complexity and manage large code base. So, that's just the feature of abstract. All right. So now we have some properties that we can we need to look at. They are not concepts of object-oriented programming, but they are just some kind of things that we have access to. So one of them is method overriding and method overloading. So in that in that programming language, we cannot overload a method, but we can override. So by override is basically what we've been doing when we extend a superclass by this. This is method overriding. So method overloading in the other case is when you create a function or a method. Now let's say this ring function. You see that this function doesn't return anything and doesn't take any inputs. To overload this function, you can write the same function again, ring. But in this case, if you try to, when you overload a function, their inputs must be different. For instance, this one doesn't have any function, but this can have a function. I mean, can have an input, call it input. But in that we do not have anything as method overloading. Method overloading is not allowed in that. But in some other programming language, you can do this. This is well accepted, right? So ring, you can, this one will complain that ring is already defined. But if there's another programming language, you'll be able to. So that's just it. Yeah. It says int add A and B. So it creates another function of the same function name, then different return type, different inputs, as you can see. So you can just call add. Whatever the value you pass in will determine the output, right? Will determine the one it will call between the two. The input you pass in will determine what the output will, I mean, which function it will call. For instance, here you just do calculate dot add. So then it passes in the input. This input will determine which of this will it call. If you pass a double input, if you pass double as your input, it knows that this is the one that accepts double. If you pass integer, it knows that this is the one that takes integer. Are you guys with me?
So,
Okay. Now looking at this, this says that we have types of inheritance. Inheritance in which new class? Uh, inheritance. Now, single properties occur when a class inherits properties of method from a single superclass. Okay, yeah. So, uh, everything we've been doing on inheritance is a single level inheritance, whereby a single class extends another class. All right. So in the case where a single class, this phone is I mean smartphone is extending phone and phone is not extending any other class. A multi-level uh inheritance is when phone is also inheritance, as in it's inherits from another superclass. Let's say we have a class called a class, we call it uh we call it GSM. Let me just use this. Now, let's say phone is extending from extend G. Now, this has become multi-level inheritance, whereby the the phone is extending from GSM and smartphone is extending from phone. Well, let's say we have class of smartphone. Then from smartphone, each manufacturer want to create their phone. You know, phone is extending from GSM. GSM is I mean, smartphone is extending from phone. Now, let's say we want to create Infinix phone, or let's say we want to create Redmi phone. Redmi phone can also, we can create an object of Redmi, which will also extend from smartphone. So this has become multi-level inheritance. That is, and when you create Redmi phone, an object of Redmi phone, it can also have access to the properties of the highest class, I mean the highest class, in this case GSM. Let's say we have some properties of GSM. Redmi can also access all the properties of GSM, even though it is not the one that is directly inheriting from the GSM. It can still access the properties of GSM. Are you guys following me?
Yes, sir.
Okay. And this is an example of single class which animal is extending from. Now, multi-level is animal, dog extend from animal, and Labrador is extending from dog. Can you see? So, animal eats, dogs barks, and Labrador can swim. So, so dog, I mean Labrador is the lowest one, and it can also have properties of this animal. I believe you guys understand you understand the class.
Yes, sir.
All right. So hierarchical inheritance involves multiple subclass inheriting from single superclass. Each subclass share common characteristics from superclass but may have their own specialized behavior. Like this animal, dog is extended from animal, cat is extended from animal. All of them can have the properties of animal. They can also have their own properties. That is hierarchical. And then encapsulation. Encapsulation is called principle of the programming language. Variables and method function that operates on data into single units. This approach restricts direct access to some object components in that achieve in variable, I mean member variable encapsulation, function encapsulation, and class encapsulation. Okay. Okay. Basically what they are saying here is um on encapsulation we can have uh we have three three ways. That is variable encapsulation by making a variable a private variable. Methods, I mean function is by making a function a private function. And we can also make a class a private class like this. So basically it's everything about, let's look at abstraction. Abstraction. So basically what we have discussed, this is process of abstraction. Okay, let's read at this. Abstraction is a key principle in object-oriented programming language that simplifies complexity system by modeling classes appropriate to the problem. It helps hiding the implementation details and showing only the functionality to the user. In that and Flutter, abstraction can be applied in various forms to create clean, maintainable, and modular code. There are different types of abstraction in object-oriented programming. Data abstraction, process abstraction, abstraction using public specifiers, and abstraction using private classifier. This data abstraction focus on exposing only essential feature and hiding unnecessary details. Data abstraction is commonly achieved using abstract class and interface. Yes. And, the implementation details of some are hidden from the animal. Oh, okay. So this process abstraction is basically when you have a function, you create a private function. Are you guys following? Are you still with me? So when you have a private function, but
Yeah.
you don't want to expose that private function, so you
Yeah.
basically create a new function. Are you saying something, Favor?
No.
Okay. So you basically create another function to call that private function. In this case, they created math operations and they create this function, calculate circle area. Now, this is a private function. Now, they now have to create a new function that calls that private function, meaning that they do not want to expose this private function. So, meaning that in the main file, you cannot directly call calculate circle area, but you can call calculate area. Do you get it? So, abstract using what's it? Using private classifier. So private classifier in that are used to encapsulate details within a class, making certain properties and methods inaccessible from outside the class. So it's still the same thing actually. So the the properties are private and also the functions are private. Now they now create a new public methods, these public methods to call the private values. Just like this one, they use get details to return the value of the private value, and as well as this bonus to calculate to call the function of to call the function of calculate bonus. So now if you look at this is a private, this is a getter function. So let's read this conclusion. In conclusion, understanding four pillars of OOP, encapsulation, inheritance, polymorphism, and assertion is essential for writing clean, maintainable, and extensible code in Dart programming and Flutter application. Additionally, grasping the concept of method overriding and overloading further enhance your ability to design and implement robust software solution. By mastering these concepts, you can leverage the full power of OOP to build sophisticated, scalable application. Comprehending these different types of inheritance and data and Flutter is crucial for designing efficient and maintainable code base. By leveraging inheritance efficiently, you can promote code reuse, establish hierarchical relationships, and build scalable application with ease. Whether you are creating simple class inheritance or designing complex object structure, inheritance plays a vital role in shaping the architecture of your Dart and Flutter projects. Feel free to share your thoughts. All right, so that comes to the end of today's class. Is there any question before we call it over? Hello, is there any question? Please and please let me reiterate it. You guys should please read and practice. Learn and practice. Don't just I know what we learn today is kind of complex, but you just need to practice. In fact, not just one practice, practice and practice and practice again. That is the only way you would get it, and you would even know which question to ask. So I will try and compile the video and send it so that it can be available. I'll also look for assignment and post it to your Slack. So if there's no question, that will be the end of today's class. Have a nice day ahead, everyone.
It's